let's get started. Alright guys, so welcome to the shop. Today we are going to turn all of this into something that resembles this. And what this is an Anthony Mark I bomb cart. So the reason that I want to do this video is because a while back I got one of the RocHobby MB Scaler 1941 Jeep crawler things. And I had a good time with it, but I wanted to come up with something that was a little more scale for aviation. I couldn't really find any bomb trailers for sale, so I thought, well, this is a simple enough thing. I could probably design this in Fusion and print it myself and use some off-the-shelf parts and make my own trailer. Turns out I was right, but as you can see, I got a little carried away. I did the design in about a day. I went from nothing to almost an entire prototype in about 24 hours. So that's the power of 3D printing right there. I'll tell you that the tires are TPU, just a generic TPU. I'm not using any fancy brands of any of my filaments. Everything else is PETG. Now, the reason I chose these different materials is because, number one, I wanted the tires to be a little bit giving because there is absolutely no suspension on these carts. Really, the tires were the suspension. And I did try a different infill pattern, and this infill pattern seemed to work the best. So see what works the best for you for your tires. I don't recommend the concentric infill pattern. I'm using Cura as my slicer. The concentric pattern made it a little bit too squishy, and on certain edges it started to come apart after just not doing a whole lot of anything. So something a little bit more robust I would definitely recommend. This is cubic subdivision for my infill pattern at 20%. 2 walls for the tires, 2 walls. Everything else, honestly, is 4 walls, unless it's a part that's small enough that it wouldn't do 4 walls. Yeah, the reason I did that is because I wanted the frames in particular to be pretty rigid, so there's not a whole lot of twisting ability. Because the frame really is, the load-bearing structure. It's not like I'm going to be carrying a tremendous amount of weight, but I do anticipate I'll be able to transport beverages around to my friends at events with this. So I did want it to be able to handle a little bit. Now, there are a couple of other things that I'm going to put links to in the description. Not all of this stuff is designed by me. And I'm a big proponent of utilizing this amazing hobby that we're in. And one of those, let's see, there's a good part. Goodson's Hobbies, it's a set of wheel hubs on Thingiverse. He's got 3, 4, 5, and 6 hole, and it's hole around the rim. This I scaled down to 40 millimeters in overall diameter and just printed it as is. Assembles with 6 screws. We'll get there in a second. The other part is a military tow loop, pintle tow loop by a user Bidome from Thingiverse. Yeah, it works really well, and I designed the frame around this to print as is, so no need to resize this at all. Everything has been printed with 0.2 millimeter or adaptive. You could probably use adaptive layer height, but for the most part it's just 0.2 millimeter. Just keep things simple, not going for a tremendous amount of detail. And honestly, in my experience and opinion, the bigger the Z-axis layers are, the stronger the part is. So we're kind of going for strong parts because it's going to probably be going over rough terrain and stuff. So we want things to be as strong as possible. So I think that's everything in terms of the printing. Let's go over the hardware after I clean up some of, well, all of this. Alright, so the hardware that we're dealing with for these is actually pretty simple. Again, I designed this to be as simple as possible to assemble using pretty common off-the-shelf items. I'm a metric person. I know I live in the United States and I love metric. Ooh, sue me. But we're using primarily M4 stuff here. We're using M4 threaded rod as our axles. And I'm also using 4 by 8 by 3 millimeter bearings. These are pretty standard off-the-shelf bearings. This is a pack of 10 of them. And then you've also got to get some M4 screws. I got these from the hardware store. I've got M4 by 0.7 thread, 16 millimeter and 20 millimeter length, and some M4 by 0.7 nuts, and a whole bunch of little tiny screws. Now the pan screws that I have are number 4 by 1/4 inch. I couldn't find these at a local hardware store, but I did able to source them easily from McMaster Carr. So that's all of the hardware. Tools, you're going to need a basic screwdriver, Phillips head screwdriver. You'll need some pliers and needle nose pliers, a hammer maybe, and that's pretty much it. I do recommend a Dremel. A drill press can help, but you can get by with just a basic drill and set of drill bits too. The reason that you want some of these power tools is that I've designed from the onset to have pretty tight tolerances so that you can do as little work as possible. What I mean by that is to press in the bearings, you'll want to sort of smooth out the inside seat of the axles. And I highly recommend a Dremel bit to do that, just because it just helps smooth things out, because you're never going to get the layering perfect unless you take forever to get the print to do in really fine resolution. So it's a compromise, right? So we're dealing with machined parts versus printed parts. And anyway, so take it for what you will, do what you want. You cannot do them if you want to just jam it in there, but you'll more than likely crack the print. Right, so the hammer, you'll want to, really you're only using the hammer for one operation. When you print the frame, I definitely recommend you print it with support. And the reason that you want that is because the axle in the frame is not directly going to sit on the print bed. It's elevated slightly. And also you are going to have support material inside of the axle print itself. So in order to get that out, what I typically had to do was take one of the M4 threaded rods, put it slightly in, and then I tapped gently with a hammer right here, alternating back and forth until it just popped through. Other tips and tricks along the way, you'll probably want a razor blade to do some mild trimming of plastics as you go. Again, tight tolerances. Loctite would be good, blue Loctite. Just as a security measure, because of the nature of how these bolt together, it was the simplest solution to sort of keep things as scale, and you'll see how that goes. It's going to be a pretty long video. It's going to take multiple days for me to assemble this, just because of order of operations and paint drying and stuff like that. So bear with me. I'm going to have a costume change eventually. So stick with me. We're going to have some fun. We'll go through this step by step, and it's not going to be hard. Let's get to it. So the first thing that I normally do is I lay out all of my parts and make sure they're nice and organized and ready to go. And here with the wheels, you're going to want to clean them up and get them ready to paint. Alright, so as the paint dries, you're going to want to go ahead and start assembling your main frame. I'm starting here with the rear hitch, and there's a recess in the frame that's designed specifically to hold this hitch. So you go ahead and just apply some glue. You can rough up the surface to help with adhesion as well. You may also find it useful to use a rasping file to square off the edges of the recess so that it sits a little bit better. I'm using a paper towel to dab away any excess glue so it doesn't do any fogging or hazing. Next up is the forward cradle, and that goes on pretty much just eyeball center from the two cross beams at the front. It's pretty straightforward. And then moving on to the second one toward the rear, you use the rails that go on the rear as a spacer, just so you get an idea of where it needs to go. Again, it doesn't have to be exact. These things were welded together pretty haphazardly anyway. Yeah, and then these rear rails get glued on as well. You want to make sure that the rails line up with the height of the cradle itself so that the bomb can be slid on in a flush way. That's how these bombs were loaded. Again, dabbing away excess glue so we don't cause any hazing or paint issues when we go to paint. The larger screws go together. This one is for the hitch in the rear portion. And now we're assembling the front yoke. The pintle hitch loop goes in the front. Add a little bit of glue there just to keep it in. It's a pretty snug fit. And then the shorter screws along with some nuts and our blue Loctite. The screws go in, and it's kind of a snug fit, but it does go in. Just screw them in, and then add the nuts and some Loctite, and then tighten the nuts a little bit. Again, this should be pretty free moving, but just get the nuts snug enough to stay on there while the Loctite is able to do its thing. We're using another longer bolt here, and this time I'm putting it up through the bottom because it looks a little more scale with two nuts on the top that sort of get locked together. And this is why you need needle nose and pliers, just to snug those together and have them torqued. So assembling the wheels is pretty straightforward. Just lay out the pieces, and you can get away with 3 screws on these, but things just press together, and you can just add 3 screws if you want, or you can do all 6. It's not going to make much of a difference. And as this is assembled, we can just speed things up here. With the frame painted after assembly, you begin by going ahead and putting your bearings in the recesses of the axles that are printed, and then you insert the threaded rods that are the axles themselves. And you're going to put the nuts on and roughly center the axle. Just eyeball it. It doesn't have to be totally perfect. And then with your needle nose and regular pliers, you're going to put additional nuts on, and this acts like a jam nut so that things don't unwind as the cart rolls. So do that on both sides of both axles, and then you'll be ready to start adding the wheels themselves. To install the wheels, you just put the wheel on simply and add a drop of Loctite, and then tighten the nut. If you ever have to replace one of these wheels, obviously the wheel is going to be destroyed anyway, so you can rip it apart and just try to unloosen the nut itself. Should come off, that's why you're using blue Loctite. And once you do this assembly process over many hours and many times, and then clean up your shop, you're rewarded with I hope you've learned something from this, maybe got inspired for another project. If not, that's okay. But I hope that you enjoy these bomb trailers. If you decide to print them yourself and assemble them, I'm looking forward to taking them to my next event and see how they go over with some of the other pilots in the pits. Until next time, keep working on your 3D printed works of art.